Okay, hello chemistry students. Here's a sample problem from section 13.1. This is problem number 11 from homework 9. Okay, so first of all, make sure as you're doing your homework, you got your resource packet, especially this, and calculator, okay? And we're going to start out by just reading the problem here. So it says a sample of air in a syringe exerts a pressure of 1.2 atmospheres at 22 degrees Celsius. The syringe is placed in a boiling water bath at 100 degrees Celsius. The pressure is increased to 1.23 atmospheres by pushing the plunger in, which reduces the volume to 0.224 milliliters. What was the initial volume? Okay, so when you first read a problem, you're probably thinking, oh my gosh, what in the world is this? There was so much information here. Where do I even start? So you always start at the beginning, and we're going to start by just reading the problem one more time and writing down things that we know. So a sample of air in a syringe exerts a pressure of 1.02 atmospheres. Okay, so that's telling me that I have an initial pressure of 1.02 atmospheres. All right, so I'm just writing down what I know here. At 22 degrees Celsius, now I'm sure you know from your notes, whenever you do a temperature in chemistry and that temperature goes into an equation, it's gotta be in Kelvin, not Celsius. So I am going to add on here to my 22 degrees Celsius, I'm going to add 273, and I'm sure you guys remember that number to get Kelvin there, all right? So just as a quick reminder, definitely something you want to use here. Kelvin always goes in an equation, and to find the temperature in Kelvin, you take your Celsius and add 273. So that's definitely, this is definitely something you're going to want to just know, okay? Okay, so it looks like we start with the syringe. This is the pressure. This is the temperature. It doesn't say anything about volume or anything. And then it looks like something changes. So the syringe is placed into a boiling water bath. So something changes. And now we're told that the temperature changes to 100 degrees Celsius. All right. So again, right away, I'm going to take that 100 Celsius and I'm going to add 273 to get to Kelvin. So that's 373 Kelvin, okay? So always convert your temperatures to Kelvin, right? The pressure is increased to 1.23 atmospheres. So what do we know there? We know the pressure has now gone up to 1.23 atmospheres, okay? And by pushing the plunger in, we reduce the volume to 0.224 milliliters. What was the initial volume? So I always like to write this out. What was the initial volume? So the subscripts 1 here mean what you started with. The subscripts 2 mean what you end up with, right? So what was the initial volume? We want to figure out what is V1, okay? So that's step number 1. Write down all the variables that you know, okay? So step 1, write down your variables. Might take you reading the problem a couple times. Convert all temperatures to Kelvin, right? And then, how do I solve this, right? I know I want to know V1, but how do I solve this? So this is where you take out your resource packet, open it up to page 8 there, right? And take a look. Well, I've got pressure changing, I've got temperature changing, and I want to solve for volume, so I have pressure and temperature and volume. Okay, which of these equations have both temperature and volume and pressure all changing simultaneously? The combined gas law, right? So I want to solve for V1. So I definitely got to have V1 in the equation. So like this Gay-Lussac's law would not work. But I've got all these other things changing. So I got to use the combined gas law, right? So I'm just going to write that down here. All right. So I'm going to use combined gas law. Okay, and the combined gas law says, I'm just going to write it down here, P1 times V1 over T1 equals P2 times V2 over T2. Okay. Now again, one more time, I'm going to check that my temperatures are in Kelvin, and then I'm going to check that the pressure units are the same unit, atmospheres, and the volume units are the same. So this will come out in milliliters, and we've got Kelvin. So, okay, our units look okay. All right. So I'm going to plug everything in now in my equation here. So P1 here is 1.02. Okay, I'm not going to write the units, so that's my P1. My V1, that's kind of like my X. That's what I'm solving for, right? T1 here was 295, so I'm going to plug that in, okay? P2 was 1.23 times V2, which is 0.224 milliliters, okay, divided by T2, which was 373. Okay, I guess I don't need the milliliters here. I'm not putting units in. Okay, so what's the easiest way to solve for V1 now? Okay, so I want to get V1 by itself. So I'm going to multiply on each side by 295 divided by 1.02, right? Because according to algebra, right, you can multiply both sides of an equation by the same thing and the equation still works. Why did I choose this funky number to multiply both sides by? Because then the 1.02 cancels out, the 295 cancels out, and I've got my answer. Okay, now I'm going to need my calculator to get the answer here, right? But basically, the answer is going to be 123 times 0.224 times 295 divided by 373 divided by 1.02. Okay, so let's see if we can practice punching that into our calculator here, right? So V1 equals, okay, so here's what I'm going to punch in. 1.23 times 0.224 times 295, and then divided by 373, and then divided by 1.02. Okay, and then I get my answer, which is volume is 0. Ooh, almost made it through the video pen. 2.1. Why don't we round this 3 up to a 4? So 0.214 milliliters. Why milliliters? Because I'm using the same unit as the other one. Okay, so this is my answer. What was the initial volume of the syringe? 0.214 milliliters. Okay, great job, chemistry students. Keep up the good work.